EoCoE is a great project that has the ambition to use exascale computing to foster and help the transition toward a clean and decarbonated energy.
In terms of energy transition, HPC is fostering the transition in two different ways. On one side is motivating the energy transition, and on the other is enabling it. So in terms of motivation, HPC enabled the possibility of executing very large weather and climate simulations, and so understanding really that we need such a transition towards clean and renewable energies. On the enabling side, it allowed to execute very complex simulations of for instance, material science simulation for new materials for production of energy, or executing large simulations for wind, for energy production from windmills, and so on. So it's really, in the end, a two-sided aspect that HPC can address.
The main scientific objective of the material work package would be simulation of novel photovoltaic materials and photovoltaic cells, like those based on molybdenum disulfide heterostructures. So these are nanoscale materials that can be stacked on top of each other, and they promise to be very efficient for energy harvesting materials.
Main scientific objectives of the wind for energy package are the simulation of large-scale wind turbines, wind farms, and all this with the goal to optimize, for example, the layout of wind turbine or wind farms for the maximization of energy production in wind energy.
The global scope of the water work package in EoCoE has to do with two sides of the same coin. On the one side, it's how do we understand the energy-water nexus, how do we model it with hydrological models, paying particular attention to hydropower and water management of hydropower reservoirs. And on the other side, how can we make efficient energy use of the supercomputers, the exascale supercomputers, on which we intend to run our hydrological models.
We can't speak about fusion without speaking about EoCoE-III, the international project under construction in Cadarache, in south of France, the tokamak, where we try to reproduce what is done in the sun and try to demonstrate the viability of the and the feasibility of the fusion on Earth. The objective of this simulation is to try, for instance, to understand, predict and control the transport in plasma of tokamaks.
The EoCoE consortium evolved quite a bit since it started, and in the final phase we have been really quested with the task of bringing the codes that operates in these four areas, so materials for energy, fusion for energy, wind for energy, and water for energy, to the next level, and be capable of really realistic and extreme scale simulation. So the idea is really to pick up the most promising codes on the market for these four areas and push them to a point where they are at the front field of science, at the frontiers of science.